Hi, this video is looking at catalysts. There is more content, quizzes and past papers on the website, which is www.elevise.co.uk. So let's get started. A catalyst increases the rate of reaction without being used up in the reaction. This means that after the reaction has taken place, the catalyst is free to catalyze other reactions. This is why we only need a small amount of the catalyst to catalyze a large mass of reactants. Catalysts will only catalyze certain reactions. For example, iron or platinum is used as a catalyst in the production of ammonia. So how do catalysts actually increase the rate of a reaction? Well, a catalyst increases the rate of reaction by offering an alternative reaction pathway for the reaction. This alternative pathway requires a lower activation energy. Activation energy is the amount of energy that is required to start a reaction process. If the activation energy is not met, the reaction will not take place. If the activation energy is met, the reaction will take place. Here is a reaction profile for a certain reaction when a catalyst is used and when a catalyst is not used. The orange line shows us when a catalyst is not used, and the purple line shows us when a catalyst is used. From the reaction profile, we can see what the activation energy is. The activation energy is the difference between the energy of the reactants and the highest energy point on the reaction profile. From the reaction profile, we can see that a lower activation energy is required when the correct catalyst is present. The presence of the catalyst does not change the overall energy change, which is the difference between the energy of the product and the energy of the reactants. From the reaction profile, we can see that the energy in the product is less than the energy in the reactants. This means that this reaction has given out energy and therefore it's an exothermic reaction. So how can we investigate whether a substance is or is not a catalyst? There are two different things that we need to test. The first is that the mass of the potential catalyst must remain unchanged, and the second one is that it increases the rate of a reaction. Let's have a look at the first one in more detail, which is that the mass of the potential catalyst must remain unchanged. If the mass of the potential catalyst does remain unchanged, it tells us that the solid was not used in the reaction and therefore it may be a catalyst. Remember that catalysts are not used in a reaction, which means that their mass should be constant before and after the reaction. We can compare the masses of the potential catalyst before and after the reaction and compare to see if the masses remain unchanged. We can find the mass of the potential catalyst after the reaction by filtering the solution, which will give us just the solid. If the masses are the same, it tells us that the solid has not been used in the reaction, which means that it may potentially be a catalyst. This brings us on to the second test, which is to test whether the potential catalyst increases the rate of reaction. We can do this by carrying out two experiments. We carry out one experiment with the potential catalyst and the other experiment without the potential catalyst. We then compare the rates of reaction. If the rate of reaction increases with the potential catalyst present, then we can say that the solid is a catalyst. If the rate of reaction remains the same, then we can say that the potential catalyst is not a catalyst. So the first step to test the potential catalyst is to see whether the potential catalyst has been used up in the reaction. We do this by comparing masses. The second step is to test whether the potential catalyst increases the rate of reaction. If the potential catalyst increases the rate of a reaction and the mass of it does not change, it tells us that this potential catalyst is a catalyst. If one or both of these do not hold, it tells us that the potential catalyst is not a catalyst for this reaction. So that brings us to the end of this video. For more content, quizzes and past papers, go on to the website, which is www.elevise.co.uk.